previous lessons, we found how to determine probabilities of these three forms. We were given some value of A or some values of A and B, and we found the probability from the standard normal distribution that that Z, the Z-score, is less than A or greater than A or between A and B. And what that involved in those cases is we had to, we generally drew a picture. So for instance, if we had this situation, we thought about a picture like this. Our value A is somewhere along here. It's a value of Z. And then we were looking for this area here. And so what we did is took the number A, so let's say for instance that A was 1.27, and so we'd look this up as a Z on our table. We went to the side that has the positive Z-scores, so we'd go down to 1.2 across to the column underneath the 7. And then when we got there, that would be right here, we'd read off this value, which is the area to the left of our A over here, and is the probability that we're looking for. In this lesson, what we're going to do is we'll be given probabilities, and we want to try to find the Z-score that corresponds. So remember, the probabilities are out here in the table, or the areas, and then when we go off to the edges, out here we find the corresponding Z's. So let's take a look at a typical sort of problem that we'll want to do. So let's start with this one. This is the simplest case. So what we're doing, you have to be a little careful. This is the word A, but this stands for a number A. Find a value of A such that the probability that Z is less than or equal to A is 0.87. So this is our probability now, or our area under the curve. So we're looking at a picture like this. Okay, and this, wherever we pick our A along here, the area to the left of it has to be 0.87. So we know that if we were right here where Z equals 0, the area to the left of that is 0.50. So to get an area of 0.87, we need to be over here somewhere. So our A would be something like this, and the 0.87 is this area right here. Now this is exactly the sort of picture that our distribution table can be used for. Here's the picture, and we have an area to the left of some value. So remembering that the areas are in the body of the table, we're looking now in the body of the table for 0.87. Now you can see the numbers in the body are actually to 4 places past the decimal. But what we want to do is find the two values that are on either side of 0.87. Those are right here. Okay, so one of them is 0.8686. and the other is 0.8708. So let's write those down. 0.8686 and 0.8708. Now what we need to do is figure out which of those two is closer to 0.87. We do that by doing a subtraction. In this case, let's take 0.8708 minus 0.87. We can see pretty easily that that's going to come out to be 0.0008. In this case over here, we want to put the 0.87 up above and subtract the 0.8686. Feel free to use your calculator if you need to. In this case, that value is going to come out to be 0.0014. So the difference between the 0.87 we have and the two values in the table is these two numbers. This shows us that 0.87 is closer to 0.8708. So that's the value we want to use in the body of the table to get our Z-score. So going back to the table, the 0.8708 is right here. And so we can see that if we read off over to the left, we get 1.1, and up here 0.03. So 1.13 is the Z that we're looking for, or the value of A. So A equals 1.13. So that's the number we were looking for in this case. All right, so that's our simplest case from previous examples. The next most challenging, of course, is this one. So now we're looking for A, so that the probability that Z is bigger than A is 0.31. So wherever we pick our A, for instance, if we pick our A to be right here, then we want the area to the right of it to be 0.31, and you can see that this is going to be more than half because we have all the way to our center line plus more. So this A actually belongs over here somewhere. So let's put it where it really should be. We'll get rid of this one. So our A is somewhere on this side. The probability is 0.31, which is the area. So what we know is that this area here is 0.31. Now, that's not the sort of area that we can use with our table. Notice our table gives us areas to the left of whatever place we're looking at. So in order to be able to use the table, all we need to do is figure out this area in here. And then we can use the table with that area. So this area, remember the total area under the curve is 1, so this area is 1 minus that 0.31. In other words, we take our full 1, get rid of that, and what's left over is what we'll have. So we've got 1 minus 0.31, which is 0.69. Okay, so that's the area in this part, and that's the kind of area we can find in the table. So we look up 0.69 in the table. Again, we need to find the value closest to it. And it looks like that number is going to be right in here. There's a 0.6915. That's bigger, so we want to go the other way. The next one below it is this 0.6879. So we have 0.6915, 0.6879. Of course, the value we're interested in is 0.69. So we come over here, subtract 0.69, we get 0.0015. Use your calculator for that if you need to. We have 0.69 here, minus 0.6879, and this one's going to come out to be 0.0021. So we can see that the closer value is the 0.6915. So we come back to the table, 0.6915 is right here, so we have 0.500. And that's the Z, which is actually just this value of A. Remember, A is a Z. These are Z's along here. So the A we're looking for is 0.50. The last case that we have is one like this. And what we did before is we would look for probabilities that our Z was between some A and B. For these kinds of things, we have to actually go between a negative A and an A. So these two numbers have to be the same but opposite sign. I gave our probability as a percent in this case, just to kind of keep us on our toes, but remember that 40% is equal to 0.40. So if we think about a picture now, in this case the picture looks like this. And so we have a negative A somewhere and an A somewhere over here. And what we know is the probability that we're between those is 0.40. So this is 0.40 out here in the center. Now again, we need a picture that looks like this. In order to use our table, we need a line and we need to be looking to the left of the line. But if we want this line to correspond with where that A is, then that means we have this area in here, which is 0.40. And if we knew what this extra piece of area was, we could add it to the 0.40. So let's think about that. If this is 0.40, then these two pieces together must be 1 minus 0.40 or 0.60. Or think of this as 40%. There's 60% in these two. That means there's 30% on each side. So this little piece right here is 0.30. And so the total area from here over is 0.70. So that's what we want to look up on the table, is 0.70. And so we come back to the table. Remember, now that's not a Z, that's an area. So again, we're looking out in this part of the table where the areas are, and the values that are closest to 0.70 would be this one. Okay, and I'm going to do this arithmetic in my head, but you could do it again using your calculator if you wanted. The difference between this and 0.70 is 0.0019. The difference over here is 0.0015. So this is the guy that's a little bit closer, 0.6985. So to get our value of A, we come out here and we have 0.52. So A is 0.52. That's this one right here. So negative A is negative 0.52. So those are the values. That's the value of A we're looking for is 0.52. The negative of it is negative 0.52. The probability of being between those two is 0.40. And that concludes our lesson. Let's remind ourselves though what we were doing. This was the reverse process from before. In this case we know the probability, which is an area in the body of the table, and we're trying to find a z value for this letter A, which is out here on the edge. So rather than going from the z to a probability or area, we're going from an area back to a z.